Okay, so this is the holiday homework of your A Math exercise 4.2. This is on remainder and factor theorem. Okay, so for question number 1, I just need you to do 1C. Use the remainder theorem to find the remainder in each of the following divisions. Okay, so we have this thing over here. So this is written as 3x plus 4 square minus 1 minus x, the whole thing cubed, divided by x. Okay, so we know that this is our divisor, this is our fx. Right? So if we want to use the remainder theorem, okay, how are we going to do that? Okay, the remainder theorem actually tells us that if we try to make this divisor equal 0, so if you're trying to make this divisor equal 0, what is the value of x? So in this case, my divisor, which is x, if I want to make it 0, I'll just divide it by 0. Okay, I'll divide it by 0. So in this case, I just need to substitute. This is my fx. If I can be clear, this thing here is my fx. Okay, and this is my divisor. Okay, so if I want to make the divisor 0, so I'll let x be 0, so I'll substitute f0 inside over here. And the remainder theorem tells me that whatever is my result, that is my remainder. Okay, so if I substitute 0 inside, I'll get 3, 4 square minus 1 minus 0 cube. I will get 47. Okay, so I repeat again. Okay, what does the remainder theorem tell us? The remainder theorem tells us is that we need to find out what makes the divisor 0. What value of x makes the whole divisor 0? This is the divisor because we're actually dividing by x. Okay, so x is our divisor. So the only way to make the divisor 0 is when x is equal to 0. We substitute in that value of x into the original polynomial that we have, okay, the dividend, and the result gives us our remainder. Okay, so that is basically what the remainder theorem is all about. Okay, let's move on to the next one. Question number 4. Use the factor theorem to determine whether dx is a factor of px. Okay, so if I'm supposed to use the factor theorem here, what does the factor theorem tell us? The factor theorem is basically a derivative of the remainder theorem. If you substitute in a particular value and you realize into the polynomial and you realize that it is equal to 0, then we know that it is a factor. Okay, so if I know that dx over here, the divisor is x minus 2, I know if I want to try to make this 0, so x minus 2 is 0, I know x must be equal to 2. So I'm going to try, okay? I'm going to substitute into the polynomial p2. Okay, I'm going to substitute in the value of x that makes the divisor equal 0. So I'm going to get 2 cubed minus 4, 2 square plus 2 minus 2. And this would give me 0. Okay, so therefore, I know that the divisor, x minus 2, is a factor. Okay, because I get 0. The remainder is 0, so therefore it is a factor. Okay, how about part B? So again, the divisor over here is 2x plus 1. I'm going to try to make it 0. So 2x plus 1 equals 0. I know that 2x equals to negative 1. X is equals to negative half. So I'm going to substitute that into the polynomial, negative half. And I'm going to get 16 cubed plus 8 negative half square minus 6 negative half minus 9. Okay, I'm missing out negative over here. And if I enter this in my calculator, I'm going to get negative 6. So what does this tell me? If 2x plus 1 is the divisor, that means I'm going to get a remainder of negative 6. So is this a factor? If you have a remainder, it is definitely not a factor. Okay, so in this case, your dx, 2x plus 1, is not a factor. Why? Because it has a remainder. Okay, it has a remainder of negative 6. Okay, moving on. Okay, question number 7. Now explain whether x minus 1 is a factor. So this is a divisor. So if I'm going to try to make this equal 0, x is equals to 1. So I'm going to try to substitute this into the original function fx. So this is my fx, which is my dividend. So my fx is x 5, 6, 7 minus 3 x 400 plus x 9 plus 2. I'm going to try to substitute 1 inside this particular function. So I'm going to get 1, 5, 6, 7 minus 3, 1, 400 plus 1 to the power of 9 plus 2. And if I enter this into my calculator, I'm going to realize I'm going to get 1 minus 3 plus 1 plus 2. And this works out to 1. And 1 is not equals to 0. So by the factor theorem, I know x minus 1 is not a factor. Alright, it is not a factor. How about part B? Find the value of k for which x plus 4 is a factor. So if I know x plus 4 is a factor, that means it's going to be equals to 0, x is equals to negative 4. So I'm going to substitute this into the dividend. So function, substitute negative 4 inside. And I know I'm going to get 0, right? If I substitute it inside this function, okay, I know that the remainder is going to be 0 because it is a factor. Okay, so I'm going to quickly substitute in negative 4 plus 11 to the power of 9 plus 2 times negative 4 plus k to the power of 3 is equals to 0. Okay, so this works out to be, let's enter this in a calculator. This one is negative 1 plus negative 8 plus k to the power of 3 is equals to 0. Don't be scared of the power of 3. I bring the 1 over. Negative 8 plus k to the power of 3 is equals to 1. Let's cube root both sides. Let's free up this cube. So I'm going to get negative 8 plus k is equals to 1. So therefore k is equals to 9. Okay, so this is how you would do this question over here. Okay, let's move on to question number 9. Now, if I'm going a little bit too fast or if you don't understand anything, please do drop me a text, all right? So make sure that you understand this. Do not just rush through this, okay? I'm going a little bit faster, but you can slow down this video if you really need to. Okay, question number 9. The expression, okay, so this is the original expression, which is the dividend, where a and b are constants, has a remainder of negative 95 when divided by the divisor x plus 2. Okay, so this is a very obvious simultaneous equation question, right? So we have the expression over here. So this is my fx, which is my dividend. And I know that it has a remainder of 95 when divided by this. Okay, I'm going to jump a little bit of steps. So I know that if I substitute in negative 2, why negative 2 again? Because this, I'm going to try to make this 0, right? So x equals negative 2. Okay, oops, let me delete off this. All right, so when I substitute this, I'm going to get a remainder of negative 95. So this is my first equation, and I can make another equation, right? I know that it has a remainder of 3 when divided by this. 2x minus 3 is 0. 2x equals to 3. X is 3 over 2. So I know that the function, if I substitute 3 over 2 inside, I'm going to get a remainder of 3. Okay, so let us work out the two equations very quickly. All right, so the first one, I'm going to substitute negative 2 inside. I'm going to get 8 negative 2 cubed plus a negative 2 square plus b negative 2 minus 9 is equals to negative 95. This is my equation number 1. I'm going to simplify things. Negative 64 plus 4a minus 2b negative 9 is equals to negative 95. And this simplifies to 4a minus 2b. I bring everything over to the right hand side. I'm going to get equals to negative 22. So this is my equation number 1. Okay, I'm going to work on the second one. So I'm going to substitute it in over here. So I'm going to get 8 3 over 2 cubed plus a 3 over 2 square plus b 3 over 2 minus 9 equals to 3. Okay, I'm using this equation over here. So this simplifies itself to 9 over 4a plus 3 over 2b equals to negative 15. Okay, so you just use your calculator, shift everything to one side. I don't really like to do fractions, so shall we just multiply by 4 throughout? If I multiply by 4 to this whole thing, I times 4, I'm going to get 9a plus 6b is equals to negative 60. Alright, so this is my equation number 2. Okay, I'm not going to tell you how to do simultaneous equations. I believe you are able to do it. Okay, so please solve this simultaneously. If you do that, you will get a is equals to negative 6, b is equals to negative 1. Always check your answer using the calculator method. Okay, your calculator can help you to solve simultaneous equations. Okay, so in order for you to do this, you can either do by elimination or you can do by substitution. If you really have problems with elimination and substitution, please message me. Okay, maybe I can give you some videos. I can send you some videos in order for you to recap on how to do simultaneous equations. Okay, all right, let's move on to the next one. Question number 13. I suspect this question, many of you would have some problems, okay? So let's read this question together. The polynomial fx, so this is our divisor, our dividend, leaves a remainder of negative 19 when divided by x plus 2 and a remainder of 2 when divided by x minus 1. So what we know is that if it's divided by the divisor x plus 2, that means when f negative 2, I'm going to get a remainder of negative 19. And a remainder of 2 when divided by x minus 1. So means when I substitute in 1 inside here, I'm going to get a remainder of 2. Again, why? Because I'm going to make this divisor equals 0, right? X minus 1 is 0, x is equals to 1. In this case, x plus 2 is 0, x is equals to negative 2. So I know that this is what I'm going to substitute it in, and I'm going to get the following. Okay, so this is the first step. Now let's look at part I. What will the degree of the remainder be if fx is divided by this? Now, remember in class I told you, okay, for part I, when you are being divided by the divisor, okay, your remainder is always going to be 1 degree less, okay? Your remainder is always going to be 1 degree less than the degree of the divisor. Now, in this case, your divisor is of degree 2. So, your remainder will either be degree 1 or it could be degree 0. Okay, it could be degree 0 if this is a factor. Okay, but are these factors? No, these are not factors because we know that they are remainder, right? We know that if it's divided by x plus 2, there's a remainder of 2. Divided by x minus 1, there's a remainder of negative 19 and 2 respectively. Okay, so we know that it is not a factor. So there is a remainder. So the remainder would have to be degree 1. Okay, so how are you going to explain? Okay, so you must say that the remainder, is always less, or the degree of the remainder is always less than the degree of divisor, right? So since x plus 2 and x minus 1 is not a factor, okay, the remainder is degree 1. Alright, so the remainder could be degree 0, which is basically nothing, a constant, okay, or it could be degree 1. Now in this case, because x plus 2 and x minus 1 is not a factor, so it means you cannot get a remainder that is basically 0, so we know that the remainder has to be degree 1. Okay, now part 2, I suspect many of you have problems, right, because you don't know how to do. Now, you must know, they never tell us what the polynomial fx is, but we can roughly write down what the polynomial fx is, right? The polynomial fx in general okay, which is basically our dividend, is equals to the divisor in general, right? I'm saying in general, is equals to the divisor multiplied by the quotient, okay, plus the remainder, right? This is the general formula for the dividend is equals to the divisor multiplied by the quotient plus the remainder. Now, we don't know what the fx is, but we do know what the dividend is, right? The dividend is x plus 1, x minus 1, x plus 2. We don't really know what the quotient is, so I'm just going to leave it as qx. But the remainder we know is of degree 1. Degree 1 is basically a linear function of the form ax plus b. Okay, so this is basically a linear function. Okay, just like how a degree 2 function will be ax squared plus bx plus c. Okay, a linear function with degree 1 will be of the form ax plus b. So this question is a little bit difficult because a lot of you are not so familiar with this. Okay, but actually once you're able to get into this stage, you should be okay. Okay, you should be okay. Okay, so let us do a substitution. Now, we understand from above, which I'm going to drag this thing down. I'm going to drag this thing down over here. Now, we understand that if we substitute it in, okay, we are going to get, let's look at the first one. If we substitute negative 2 inside the original function over here, we are going to get a remainder of negative 19. So let us try. Okay, so if I substitute in f negative 2, I'm going to get negative 2 minus 1, negative 2 plus 2, qx plus ax plus b is equals to negative 19. Okay, just so nice, this thing is going to give me 0, because negative 2 plus 2 is 0, and 0 times qx, anything times 0 is just 0, so straight away I'm going to get let me check. I think there's something wrong here. Sorry, my apologies. Here, my x is negative 2. So I forgot to substitute negative 2 in here as well. Okay, so here, this whole thing becomes 0, so it cancels out. What I'm left with is just negative 2a plus b is equals to negative 19. Okay, so this is my equation 1. Okay, how about my equation 2? Okay, I'm going to substitute in 1 inside this equation. I'm going to realize I'm going to get the same thing, right? 1 minus 1, 1 plus 2, qx plus, my x is 1, so we're going to a plus b is equals to 2. Okay, so if I do that, I'm going to get a plus b is equals to 2. Why? Because 1 plus 1 gives me 0. This whole thing is going to cancel out. I'm just going to left with a plus b is equals to 2. So this is my equation 2. Again, I got 2 equations over here. You can do by elimination. That will be the easiest. Okay, and you are going to get a is equals to 7 and b is equals to negative 5. Again, if you do not know how to do by simultaneous equation, please message me. Okay, please do message me. Okay, so what does the question actually want us to find? Find the remainder when fx is divided by x minus 1, x plus 2. Okay, so we know that the remainder is of the form, I know that the remainder, okay, which is remainder rx, is a linear function of degree 1, so it's in general is ax plus b, and in this case a is 7, so here I'm going to get 7x plus or negative 5. Okay, so this is my remainder. Okay, so this is how you do this question. I suspect this one might be the toughest question of all. The concept, once I explain it, I hope you understand a little bit better. Okay, but this is a really good question. Okay, it's a really good question. I may want to insert in this question in the exam, I don't know. Okay, but please do practice it. Okay, please do practice it. Okay, to make sure that you are familiarize yourself with it. All right. Okay, the next question, question number 15. Now the expression has the same remainder when divided by x plus b and by this. So this is the divisor. Okay, so I know that what they are telling me is that if I try to make this 0, okay, x plus p is 0, so x equals negative p. And in this case, If I want to make it 0, x minus 2q is 0, so x is equals to 2q. So what they are trying to say is that if I substitute in this here as negative p, it is equals, the remainder is equals to the same thing if I substitute in 2q. Okay, so if I were to substitute it into the original function fx, I'm going to get 2 negative p square plus 6 negative p plus 3. It will be equals to the same thing when I substitute the 2q inside. 2q square plus 6, 2q plus 3. Okay, so if you were to simplify this whole thing out, let's simplify this whole thing out. 2p square minus 6p plus 3 is equals to 8q square plus 12q plus 3. Okay, and let's simplify some more. 2p square minus 6p is equals to 8q square plus 12q. Okay, let's shift everything over to the left hand side. 2p square, or let's simplify things first lah. Divide by 2 throughout. P square minus 3p, 4q square plus 6q. I'm going to shift everything. P square minus 3p minus 4q square plus 6q equals 0. I noticed that this and this, okay, p square minus 4q square, I'll get minus 3p plus 6q is 0. This is a little bit familiar because I see a negative 4. I can express this as 2q square, right? And 3 and 6, I could probably factorize out a negative 3. If I do that, I'm going to get p minus 2q, okay? And this one is of the form a square minus b square. So I'm going to form a square minus b square is a minus b, a plus b, p minus 2q is equals to 0. Here I can factorize out this, p minus 2q. Let's factorize this out. What's left behind is p plus 2q minus 3 is equals to 0. So therefore, okay, the product law of 0 tells me that p minus 2q is equals to 0, or p plus 2q minus 3 is equals to 0. But the question actually says that p cannot be equals to negative 2q, because in this case, p is equals to 2q. Okay? Wait a minute, did I make a mistake somewhere? Sorry, this is a plus. Right, this is a plus. Okay, wait, I made a mistake here. This one, if I bring it over, is a negative. No wonder, the answer is a bit wrong. Okay, so here should be a plus. So I should factorize out the plus. And what I should be left with, in this case, is going to be p minus 2q minus 3. Okay, my apologies. So this is a plus. So I must reject this one. Okay, so I have to reject this one. And so, of course, this is my other answer. So my p plus 2q, here's minus. Okay, so my p minus 2q is equals to 3. Okay, so that's what the question actually wants me to find. Find the value of p minus 2q. Okay, so this is another difficult one because sometimes you don't really know the steps. This is a bit unique. Okay, so sometimes when this happens, you just got to do substitution and then try. Okay, try to work out towards the end. But I admit this one is a little bit tricky. Okay, and I apologize because I had some mistake earlier. I hope it doesn't confuse you. If you are confused, please do just drop me a text. Okay, I'll try to explain to you why it is that way. All right. Okay. If not, let us go to the last and final question. The last and final question is probably not too difficult. Okay, you should be able to do it. Okay, the function f is defined by fx blah blah blah, where p is a constant. When we are told that it has a factor of x minus 1, so for part I know that I just need to substitute 1 inside the function. Okay, and it's going to be equals to 0 because it is a factor. So that's what the factor theorem tells us. So I'm going to get 2p plus 1 multiplied by 1 square plus p times 1 plus 2p, 2p square, and this whole thing is going to be equal to 0. Okay, so 2p plus 1 plus p plus 2p square is equal to 0. So 2p square plus 3p plus 1 is equal to 0. If you were to, you can use your calculator, you'll find that p is equals to negative half, or p is equals to negative 1. Of course, in this case, if I use calculator, but you have to show the full working, negative b plus minus b square minus 4ac over 2a. So I expect you to know that, okay, my b is 3, negative 3 plus minus 3 square minus 4 times 2 times 1 over 2 times 2. Alright, then you'll get these two working. So this is important. You need to show me this during the exam. You cannot just straight away jump to the final answer. Okay, in the homework solutions, I do jump a little bit. Alright, I do jump a little bit because this is A math. Okay, we are going through the concepts, not really through the lengthy working. Okay, but when you're doing it at home, please do it right. Okay, so for part 2, so same thing, okay, because I'm told that x plus 2 is a factor, so I can substitute in negative 2. I'm not going to get 0. So I'm going to get 2p plus 1, negative 2 square plus p negative 2 plus 2p square equals 0. Let's expand this for 2p plus 1 minus 2p plus 2p square equals to 0. So I'm going to get 2p square plus 6p plus 4 is equals to 0. Divide by 2 throughout. P square plus 6p plus 4 is 0. Again, here, same thing. I can use my quadratic formula. I'm going to get p is negative 2 or p is equals to negative 1. Now, for part 3, okay, what is the value of p when fx has a factor of x plus 2 but not x minus 1? So how are you going to do this? Actually, this one just need to look. Okay, can you see that both of them have p equals to negative 1? Okay, but in this case, we can only accept when x plus 2 is a factor. Okay, when x plus 2 is a factor, which is this one. Okay, we know that it has two answers, negative 2 and negative 1. But we know that this is not a factor. So we cannot accept p equals to negative 1, even though both have the factor p equals negative 1. Because I know that if p is equals to negative 1, then f x minus 1 is a factor. Okay? So, hence, this is for part 3, hence, p is equals to negative 2. Okay? Because p cannot be negative 1. Okay? So this is a really, really simple one. Alright, so please do your corrections. Like I said, if you have any questions, please do drop me a text. If not, I'll see you soon in class. Bye-bye.